Today we're going to talk about some of the common parent functions. This isn't all the functions we see, but these are quite a few that come up quite often within calculus. Um, Keep in mind, I am excluding logarithmic and trig and inverse trig, and also exponential functions, just because that gets a bit more complicated and talks more about the rules of algebra and stuff. But we have some common ones. So before we actually start talking about the list, all right, what is the definition of a parent function? Well, a parent function is any function. Let's title it f. It's the most basic form of a function, and so what that means is there isn't any transformations applied. So the first one we have is a linear function, right? The most basic case is actually down here. Y is equal to c. It's a constant, and it's a horizontal line graphed geometrically. Pretty much, there's no slope at all. It just stays flat. It doesn't change as x changes. In the second case for a parent function of a linear function is y is equal to x. If you guys remember, y is equal to mx plus b. Alright, so it starts at the origin and goes up one, and it goes up with slope 1, rises and runs 1. Pretty much, this being seen, this is a common function that we use quite a bit as well. So let's move on. So the next we have power functions, which we call polynomials. And you could say a linear function is a power function of degree 1, where we have power functions that, so let's write that out. Degree 1. Alright. Whereas these are power functions, also known as polynomials, and essentially the powers are greater than 1, and some of them are even, some of them are odd. All right, so if n's even, we get a similar shape to a parabola. This is the x squared graph, also known as a quadratic. It's the most basic form of it. All right, and pretty much what it means is the function has two tails up. So the tails of the function, so these pieces of the function are pointing straight up. Sorry, guys. All right. So, and it's also symmetrical with the y-axis. All right. So then there's another case for power functions, n being odd. All right. This is what we call a cubic. The most basic form is a cubic. And it has one tail up. So it's this and this, and it's right there. It's symmetric with the origin. Okay. So both of these make up polynomial functions, and there's so many different kinds of transformations that apply to polynomials. Okay. So moving on. All right, we have root functions, also known as radical functions. All right, and similar to polynomials, we have polynomials or power functions. Root functions, also known as radical functions, have cases if they're even, or if the root is even or odd. If it's even roots, all right, by definition we can't have a negative number in the roots, so we start from 0 and it goes all the way to the left, and it might change based off of its transformations, but it starts at 0. So x has to be greater than or equal to 0. All right, and that's its domain. Whereas this domain is so where if it's odd, we get a similar case to a cubic, but instead of going up like this, we actually inverted it in a way, and because it's a odd root, we could say this is just a we could say the tails is go up like an even root, and also go down like an inverse or a reflected even root. So it's also symmetric with the origin. Okay, so then we have these are common cases, and also the domain for this one is all real numbers. All right, so backtracking real quick. So the domain and range for all of these is all real numbers, and same with the linear functions, all real numbers, because there isn't anything that makes it undefined. All right, so next we have reciprocal functions, also known as we have a reciprocal function known as the rational functions, commonly in calculus or in our math books. And so it has one restriction. All right, x cannot equal 0. X cannot be 0. If x is 0, it becomes undefined in the denominator. This expression, f of x is equal 1 over x to n, becomes undefined. All right, and like the last two types of functions, they have two separate cases if depending on the degree. And being odd, of course, we get something really close to a hyperbola, a hyperbolic function, but really there's a vertical asymptote, and one goes straight down, and so one goes from increasing from 0 to decreasing to negative direction, and on the right side it goes from positive infinity. It goes from increasing infinitely to 0 in the right direction, and we could talk about that in a future video, but we'll be talking about that quite a bit when it comes to the root functions. But then we have an odd case. Even. My bad. Okay. Sorry for the poor drawing here. I was struggling with my pen here when I was writing these out, but pretty much we have a similar case, but instead of so there's still an asymptote like here, but instead of it being like the odd case, we have so pretty much we draw it from it goes from 0 and increases to an infinitely large number on the left side if it's even, and we get another case where it goes from a positive number infinitely large to 0 on the right side. And we could always draw the graph out or plot the points, which we will do once we do rational functions. And so rational functions are really commonly done. It's actually one of the first ones we do when it comes to mathematics. And then we have a couple common functions that really come up a lot. The absolute value functions. All right, we'll talk about the definition later, but pretty much it's a piecewise function made of two linear functions: a positive x if x is greater than or equal to 0, and negative x if x is less than or equal to 0. And it makes this v that increase infinitely. It's similar to a parabola. It's similar, but you see that sharp. It's similar to a even polynomial, but there's a sharp turn right here, and that comes up in calculus when we try to derive it. And then we also have a greatest integer function, also known as a floor. The floor of the function, or the floor and ceiling. So the floor function pretty much we take the least number possible. So we so as we're going So as we're going in between values, we take the lowest number possible for the floor, and we get the staircase, pretty much. So say it's A, so all the values at A stays the same for this for this A prime. Okay, this A prime value, it just stays the same throughout. So if it's like 5.1, it'll be 5. 5.2, the functional value is 5. 5.4, it'll be so on and so forth. And the ceiling function is similar, but we start with it's inverted a little bit, or it's backwards pretty much. We take the highest value possible. Alright, so the floor, we take the lowest value possible, the ceiling we take the highest. And we'll talk about that in depth in a future video. But with that being said, guys, see you guys next video.